Hi, I'm Craig Clark, and I'm going to talk to you about high-altitude wind turbines in Canada. Due to high electrical costs in the Northwest Territories, the government of the Northwest Territories has increased funding in 2013 for renewable energy resources. High-altitude wind turbines could be used as an efficient source of energy in the Northwest Territories. Alright, we're going to talk about high-altitude wind turbines in general, then the Northwest Territories Energy Action Plan, and using high-altitude wind turbines in the Northwest Territories. So high-altitude wind turbines, what are they? They're defined by using tethers instead of towers to have the turbine projected into the air. They generate at higher altitudes. Higher altitudes lead to more power. There's over 100 patents of designs in the US alone. Airborne wind turbines and flying electronic generators are other names of high-altitude wind turbines. There are four main types of these turbines. The first, the kite, the kite-tune, the tethered autogen, and finally the balloon. So the kite turbine, you can see in the picture on the right, it has a kite that is projected high into the air. The generation of electricity still happens on the ground due to the pulling and pushing of the kite. A kite-tune turbine is defined by having the entire turbine rotate due to the Magnus effect, rather than having a normal generator that we see in traditional tower turbines. Tethered autogens, you can see on the picture, looks like a plane. They can also look like drones. They normally have multiple generators on a turbine, but they fly at higher altitudes than any other high altitude wind turbine. They have issues with safety factors though. Balloon turbines are most likely the most safe turbine that can be put into high altitudes. It still uses a typical generator that you'd find on a tower turbine, and this will be the one that we talk about most in this presentation. Here's just a comparison of the turbines. You can see the generation in the first column. Safety, as we mentioned, the Google X, which is a autogen turbine, is more at risk than the balloon turbine. Where they're being tested, objectives to overcome is important, as some are trying to replace normal tower turbines on and offshore, and others are looking for remote locations or disaster relief. So the action plan for the Northwest Territories, first we looked at the hydro because it's currently the highest generating energy factor in the Northwest Territories. Solar is being implemented as well with their smart grid technology. The issue with solar is it's not as efficient year-round as other sources. As you can see in the fall and winter, sometimes there's less than 5 hours a day of solar. Also, there's 55 to 60% overcast within the year. Wind, the Storm Hills project is a traditional turbine setup, but it could be $30 million in transmission lines just to have that energy transmitted to other places. There obviously won't be one solution to fixing the energy problem in the Northwest Territories. What's important from this chart here is the bottom arrow, the Alternative Energy Technology Program, as they're putting in $300,000 a year for new energy projects, which could be high altitude wind turbines. So use in Northwest Territories. Places that are using diesel as their primary energy source are using a lot more energy at higher costs. Places like this are communities and mining facilities. Some of the costs are up to 60 cents a kilowatt hour. We can bring that down by using wind energy. The predicted cost is 18 cents a kilowatt hour. That's from the Alterra's energy site, this company that made this bat turbine you can see in the picture. The bat turbine is also a balloon type turbine. They're designed to withstand 100-mile-per-hour winds, which is suitable for the Northwest Territories as they do have heavy winds. They can also withstand the weather conditions such as precipitation like snow, freezing rain, and just rain. There's two tethers that help balance the system. They also help the system dock when harsh conditions happen. The system will dock to its ground station. You can see at the bottom of the picture here. They can still generate on the ground, although it's not near as efficient as when it's high in the air. There's other uses for these turbines as well, along with the electrical generation. They can cover data so they can bring internet to remote locations in the Northwest Territories, be a cell phone towers for cell service, or a local weather gathering system. So there are some challenges for the high altitude wind turbines to overcome in the Northwest Territories. They'll need multiple turbines to replace the generators, as the turbines were only rated for 30 kilowatts. Most the communities would average 28 megawatts, so there need to be multiple of the turbines for that. Industries, it varies depending on how much energy they need. Refill helium every 3 months. This is an issue as helium costs are increasing, and it's an ongoing cost that the turbine will need. Turbines make areas a no-fly zone. Rule of thumb is a kilometer away from the turbine. This is just to protect planes from running into the turbines. So in conclusion, the Northwest Territories need renewable energy solutions. Wind is a potential resource. They are looking for alternative solutions, so high altitude wind turbines would be considered. There are four main types of high altitude wind turbines, as we discussed: the kite, the kitoon, tethered autogen, the balloon, and Alturo's Energy has a high altitude wind turbine testing already in these northern conditions. We're excited.